Welcome to the Summer Astronomy Lecture Series organized by the Nehru Planetarium, New Delhi. While preparing for this talk, I had an option of talking to you about a lot of basic stuff about using an amateur telescope. But considering that this is a web talk and it is generally very difficult to watch videos longer than 10 or 15 minutes over the internet, I could have only superficially covered all those things in this time. So instead, I decided to go beyond the basics and talk about a very important aspect of tweaking your telescope, which will push its performance and significantly improve the quality of view. Collimation. It means aligning the three optical parts of the telescope, namely the primary mirror, secondary mirror, and the eyepiece. It involves adjusting the mirrors of the telescope so that everything is aligned well and the stars become nice round dots rather than flared smudges. In this talk, I will be explaining the little-known four-step process to accurately collimate your Newtonian reflector telescope, which will not only give you sharper stars but also better contrast in observing the planets. In fact, you will love this demonstration because I'm going to do it live on an 8-inch Newtonian reflector telescope, and you will never fear collimation again in your life. One of the most joyful parts of amateur astronomy is to observe the starry heavens with your own telescope. Whether you observe the farthest galaxies, nearby star clusters, or are happy observing the planets or the moon, the views of the heavens are stunning and are heavenly in a very literal sense. Perhaps this is why you have invested in an expensive telescope, even though you know that you will be only taking it out to the dark sky observing only few times in a year. Every amateur astronomer wants their telescope to deliver its best during these limited visits. A popular quote says, "Bad collimation is the #1 killer of the telescopes worldwide." Walter Scott, Houston. Collimating your telescope could be the single most important improvement you could do to improve the quality of the view in the telescope. Miscollimation is also one of the easier to fix problems out of the many other which could introduce aberrations or imperfections in the telescope. For example, a poorly ground mirror. It cannot be corrected. A good Newtonian telescope is a great performer when it is well collimated, so it makes sense to spend some time to learn how to collimate your telescope. What happens if a scope is not properly collimated? Well, there are several problems which will come up. 1. The position of the best focus will not be located in the center of the eyepiece. What it means is that no matter how much you try to focus back and forth, the stars in the center will not focus properly. Number 2, if the collimation is very bad, the stars will display a flaring, something looking like a funnel or a conical shape. Astronomers call this shape a coma, as you can see in the image. That's a star which is more looking like a comet. An inexperienced amateur will try to keep focusing back and forth. In a well collimated telescope, stars simply snap into focus and appear as nice round dots. Third problem, moon or planets will have details smeared and never be crisp, while in a well collimated telescope, the details in the bands of Jupiter's or rings of Saturn will pop into view with great clarity even at high magnifications. Even a small miscollimation can make the aperture of your telescope underperform, while on the other hand, even a slight improvement can dramatically improve the quality of your telescope. Now we have a diagram of a perfect Newtonian reflector telescope. It's a ray diagram. I want you to focus on the parts and the names of these things. First of all, we have the telescope tube. At the back, we have the mirror mount or the mirror cell. You can see the collimation screws. There are 3 collimation screws which I will be showing you in detail later on. We have the mirror, and which is at the back of the tube, and we have a smaller mirror in front of the opening of the tube, which is mounted at 45 degree, and then on top right of the tube you can see the focuser. Another thing to notice is the optical axis of the tube. There's a dotted line shown in the middle of the tube running parallel to it, and same way there is an optical axis of the eyepiece. Now in a perfect telescope, what do we have? We have light rays which are coming parallel to the tube. They are parallel to the tube axis. The axis of the mirror is also parallel to the axis of the tube. The diagonal mirror is absolutely in the center of the tube and is precisely at 45 degrees tilted to the optical axis of the primary mirror, and it bends the light 90 degrees, which is again the axis is matching with the axis of the eyepiece. So this is a perfect telescope. If you have a Newtonian reflector telescope, it most likely needs collimation. Don't assume that it is collimated just because it is factory, it has come out of a factory. So it is very likely that the mirrors of your telescope are knocked out of alignment because of traveling or handling, or sometimes even you have to reassemble the mirrors when you reach the observation spot. If this is so, your telescope optics could be aligned more as shown in this illustration. I want you to notice the image on the left. Once again, that is an optical diagram of a perfectly collimated mirror. The light rays are parallel to the optical axis of the primary mirror, and the light rays converge on this optical axis, and that is when we get a sharp focus. While on the right hand side, the optical axis of the mirror is not matching with the rays. This is what happens in an uncollimated telescope, where the primary mirror is out of alignment. Now you can see all the light rays are not meeting at one particular place. This is the reason why we get this kind of stars. Also, in this diagram we can see the red colored line is the optical axis of the eyepiece, and the blue colored line is the optical axis of the primary mirror. In the left hand image they are parallel, but in the right hand image they are not parallel. This is what happens in an uncollimated telescope. Now you can clearly see that this is the reason why we will not have the stars in the center focus properly. So why is it that the Newtonian reflector telescopes suffer from the problem of collimation? One reason is the mirrors are not held rigidly on the mirror cell. This is to avoid the stress that could bend it and change the optical figure. So this could make the mirror shift slightly whenever you transport or shake the tube. Another reason is in case the spider which is holding the secondary mirror is not strong enough or is not tight enough, the secondary mirror could shake when you transport the tube. Also, another reason could be that in case of truss tube Dobsonian which require dismantling or assembling at the site, you need to mount the mirror on the site where you need to collimate it before you start observing.